Hello everyone, welcome back. Last week we did demand supply in the market and solved for equilibrium. This week we are going to focus more on the concept of efficiency. In order to do that, we'll be discussing the concepts of consumer surplus, producer surplus, and then total surplus. Consumer surplus can be calculated by looking at the net gain for each buyer of the good who has purchased the good. Now, what is the net gain? The net gain is simply the difference between the buyer's willingness to pay and the actual price paid. We can write it as consumer surplus for individual I is the difference between his or her willingness to pay and the purchase price of the good. If we calculate the consumer surplus for all individuals in this market who end up purchasing the good and sum it up, we will get the total consumer surplus in this market. So overall consumer surplus would be the summation of individual consumer surplus for all of these n individuals. What is willingness to pay? Willingness to pay is your maximum price that you're willing to pay for a particular unit of a good. Now, this maximum price is derived from your perceived marginal benefit. So if I assume that I'm willing to buy a used textbook and I'm willing to pay $40 for it, that's my maximum price that I'm willing to pay for it. Why am I willing to pay $40? Because I perceive that I will get a $40 additional benefit by purchasing this particular textbook. So willingness to pay is just another way of looking at the marginal benefit received by the consumer by purchasing the good. Now here we have an example and we'll see how by just putting the consumer surplus for different individuals on a two-dimensional space, we end up getting our demand curve. So we have 5 buyers in this market, all the way from Alicia to Alina, and they have different willingness to pay. Note we have arranged them here in descending order, starting with Alicia with the highest willingness to pay and then going all the way down to Alina who has the lowest willingness to pay in this group. So here I have Alicia's willingness to pay of $59, then Ben's is $45, next is Chloe's $35, Darsh $25, and Alina's $10. So I'll also, just as a reminder, write willingness to pay is simply the marginal benefit curve also. We will call this descending order of willingness to pay our demand curve. Why is this also called the demand curve? Remember, the relationship that the demand curve is showing you is between price and quantity demanded. And we typically observe that higher the price, lower is the quantity demanded, or lower the price, higher is the quantity demanded. So let's see what's happening over here. Why is this giving us the demand curve in this particular market? If the price is higher than $59, none of these individuals is willing to pay this price. So any price above 59, let's say $60 or $70, nobody is willing to buy the good, and price of 60, let's say, gives you quantity demanded of 0. If the price falls to $59, only Alicia is willing to pay that price and quantity demanded is 1. As long as price is above 45 but 59 or lower, quantity demanded stays stuck at 1. As soon as the price is $45, we'll see that both Alicia and Ben are willing to buy the good. So as soon as price drops to 45, quantity demanded rises to 2. Likewise, you'll see as price drops to 35, now all 3 are willing to pay for this good. Note that you're never willing to pay for the good if the actual price is higher than your own willingness to pay. So in a price case, in a case of price of $60, nobody wants to pay. But as the price is falling, we are seeing that more and more people are willing to pay this price, and hence the quantity demanded is also gradually increasing. So by simply arranging the willingness to pay on this two-dimensional space, we have derived the demand curve for this textbook or the used textbooks in particular in this market. Now remember, consumer surplus is the net gain to each consumer who purchases the good, and total consumer surplus would simply be the summation of all of these individual consumer surpluses. The term consumer surplus can be used both for individual consumer surplus and also for the total consumer surplus. So we use it interchangeably. Now let's calculate the consumer surplus in this market when the price is $30. Note that a price of $30 Darsh and Alina are not going to buy the textbook because they are willing to pay prices of $25 and $10 respectively. And both 25 and 10 is a willingness to pay which is lower than this price of 30. So Darsh and Alina are not going to be part of this market outcome. If the price is 30, the maximum quantity demanded in this market would be only 3 units. Why 3? Because Alicia, Ben, and Chloe are the only one who are going to purchase the textbook. Alicia wants to pay $59 at the maximum, Ben $45, and Chloe $35. So all three have a willingness to pay, in this case, above $30. So they are the ones who are willing to purchase the textbook. So total quantity demanded at a price of 30 would be 3 units. And now we can calculate the consumer surplus of each individual who purchases the textbook. So let's start with Chloe. Chloe has a consumer surplus or net gain of $5 only, which is simply the difference between her willingness to pay and the market price. Next, we have Ben. Ben wants to buy the good because he's willing to pay $45 and the price is 30, so he gets a net gain of 15. And that's Ben's consumer surplus. And lastly, we have Alicia's, whose willingness to pay is $59 and the market price is 30. So her consumer surplus is $29. Consumer surplus in this market would be the summation of all three, which is 29 plus 15 plus 5, and that gives you a total consumer surplus of $49. Now that's consumer surplus in our market given a particular price. Here we were assuming the price is $30. Now this is what we call a step curve or a discrete demand curve. We can also calculate a consumer surplus where the information is just simply given to you without a visual representation. So here's an example for George, who's considering buying some t-shirts. Now he's willing to pay $35 for the first one, $25 for the second one, and $15 for the third one. Note that his willingness to pay is decreasing for each additional shirt that he wants to buy. Market price in this case is given to us as $28. So I would like you to pause the video over here and try and answering this question on your own first before you go ahead and watch my answer. So you should be able to figure out how many shirts will George buy? What is the efficient number of shirts that he should be buying? And secondly, can you calculate the dollar value of the consumer surplus that he will end up getting? So if you've tried this on your own already, let's look at the answer. George is willing to pay $35 for the first shirt and the price is $28. So he's definitely going to buy the first shirt. He will never buy the second shirt or the third shirt because he's willing to pay prices for these two shirts which are much lower than the market price, the price at which the shirts are being sold. So he only ends up buying one shirt. And how much is his total consumer surplus? That's very simple to calculate in this case. Willingness to pay minus the price paid is $7 for George. So that is his total consumer surplus in this scenario. Let's now calculate the consumer surplus for a continuous demand curve. This is very similar to the demand curve we saw in chapter 3. It's a linear demand curve with an intercept of 900. Remember, the height of the demand curve at any particular point gives you the willingness to pay for that particular quantity. So demand curve is your willingness to pay or your marginal benefit curve. Now, if the price in this case is $500 per unit or per tablet, we can calculate the consumer surplus as area of this triangle. Why are we calculating consumer surplus as this entire area? Because remember, consumer surplus is the difference between willingness to pay minus price. Now, willingness to pay is given by the height of the demand curve minus the purchase price. We sum it up for all of these consumers and that will give you the consumer surplus of this market. Now, a simpler way of, instead of summing up for many consumers, in this case, million tablets, we'd rather just calculate the area of the triangle. So what's the area of a triangle? If half times base times height. So let's plug in our numbers. We have a base of 1 million and we have a height of 900 minus 500, which is 400. And that gives you consumer surplus of $200 million. Why am I using the unit of million? Because we have quantity of tablets being sold is 1 million. So we are working with a very large quantity. So make sure you're working with the correct units. So with the continuous demand curve, you can simply calculate the consumer surplus as the area of the triangle. Which triangle? This is the A triangle, which is below the demand curve and above the purchase price till the quantity bought. In this case, the quantity bought was 1 million, and the intercept of the triangle comes in handy. It's 900 minus 500. This is the height that we're working with for the area of the triangle. Let's now look at what happens if price changes and how does it affect consumer surplus. Let's do a fall in price. Note that when price falls, it will have two particular effects on our consumer surplus. First of all, when price goes down, consumers who have already bought the textbook at the original price, they are now seeing a net gain in their consumer surplus. So their consumer surplus will definitely go up. So one positive effect is coming from consumers who are already purchasing the good at the original price. Now with the lower price, their willingness to pay minus price paid difference is now bigger than before. So consumer surplus is therefore going up. Another thing to note is that when price goes down, we have additional buyers who are persuaded to buy the textbook at the lower price. So you have now buyers who did not buy the book earlier but are definitely buying the book now, and therefore we must include their consumer surplus into our total consumer surplus calculation. Let's look at this scenario with the help of our textbook example. So here we had Alicia, Brad, Claudia, Darren, and Edwina. And now we have the price of $30. At $30, remember, we had only these three individuals buying the textbook. Now, if the price falls, you can see consumer surplus will go up because Darren is persuaded to buy the textbook also. So quantity demanded is increasing by 1 unit. So we must include the consumer surplus of this additional buyer. Also note that all three original buyers, Alicia, Brad, and Claudia, their consumer surplus is going up. And why is it going up? Because they're seeing a drop in price for this existing quantity. So this darker blue area is the change in consumer surplus coming from your original buyers. And this lighter blue area is indicating the additional consumer surplus because of buyers who are persuaded to buy the book now at the lower price. So there are always two effects when we see price going up or down. In this case, overall we see consumer surplus will always increase. Try doing vice versa. What do you think will happen when price goes up? How will consumer surplus be affected? As a basic, scenario, just do the reverse of what we have done over here. When price goes up, note what will happen to some buyers. Are they still buying the book or not? And overall, what happens to the consumer surplus of buyers who had bought the book originally as well and are still buying the book? So opposite direction, try doing that one on your own. With the continuous demand curve, scenario is the same. It's very similar as before, but now instead of just working with a step diagram or a step curve, you're working with a continuous linear demand curve. So here we had originally a price of $2,000 and now price goes down to $500. At price of $2,000, we had only 200,000 people buying tablets, but at a price of $500, we have many additional buyers. So 800,000 buyers have been added. What more additional tablets are being sold now? So we must include the consumer surplus of all of these new buyers who are now persuaded to buy the tablet at the lower price. Also note that what's happening to the consumer surplus of your original buyers. Consumer surplus of your original buyers, which was just this tiny little triangle over here, has drastically increased by this area. And we can shade it. And this is your additional consumer surplus coming from original buyers. Overall change in consumer surplus would be both of these areas. So if I label it as A, B, C, original consumer surplus was only area A, and the new consumer surplus is A, B, C. The change in consumer surplus is given by these two. So we have gain of B and gain of C. Area B is indicating the additional consumer surplus for your original buyers, and area C is indicating the gain in consumer surplus coming from new buyers. Just like we calculated consumer surplus for consumers who end up purchasing the good at a given price, we can also calculate the producer surplus. Now, individual producer surplus is simply the net gain for a seller who ends up selling a good. How do we calculate it? It's simply the difference between the market price at which he or she sells the good minus the cost of producing that particular unit. So individual producer surplus is price minus the cost of that particular unit. Therefore, we can also call it the marginal cost, because I'm looking at the marginal cost or the cost of this particular unit. This cost at which you're willing to sell the unit is also called your minimum acceptable price. This is the minimum possible you'll accept for producing and selling a particular good or service. So for example, if it costs me $10 to produce a pen, I will never accept a price lower than $10. So minimum acceptable price for a seller is always equal to his or her marginal cost of producing that particular unit. So it's the lowest price or the minimum price that you're willing to accept. Difference between your cost and the actual price you receive is your net gain as a seller. If we want to calculate total producer surplus in a market, we will simply sum up the individual producer surpluses of all of these producers in our market, and that will give you our total producer surplus. Again, remember, producer surplus, the term itself can be used interchangeably, both for individual producer surplus and for total producer surplus in a given market. Let's look at an example. I have 5 different individuals over here who have different costs for producing and selling a textbook. And let's say for simplicity, it's a used textbook market. So each different seller over here has a different cost. Now, since this is the cost of each additional good in this market, we can call it our marginal cost column. And remember, the cost of the good is also your minimum acceptable price. So you can also call it minimum AP. If I arrange this cost column in ascending order, so starting from the lowest all the way to the top or the highest, we can end up getting a marginal cost curve, or essentially the supply curve for this market. Why are we calling this the supply curve? Recall the relationship shown between price and quantity supplied on the supply curve. It shows us that when price goes up, it causes quantity supplied to also increase. Price goes down, quantity supplied should decrease. So let's see what's happening over here. All I've done is I've taken this marginal cost column, or the minimum acceptable price for each different seller, and placed it on this 2-dimensional space. I have quantity on the x-axis and price of books on the y-axis. Now note, at a price of $4 or $3 or any price below $5, nobody is willing to sell their textbook, because the minimum acceptable price given this data set is only $5. So the price must be at least $5 for the first unit of the textbook to be supplied in this market. If the price is 5 or higher but lower than 15, only Andrew is willing to sell the textbook. So quantity supplied is simply 1. As price rises to 15, now we have both Andrew and Brianna willing to sell the textbook. So price goes to 15, quantity supplied increases to 2 units. And as price goes up to 25, now we have all 3, Andrew, Brianna, and Carlos, willing to sell their textbooks. Note, as price keeps on going up, quantity supplied keeps on increasing. With this very limited market of 5 sellers, even if price goes up to 50 or 60 or 70, because we have no additional textbooks and no additional sellers, quantity supplied is maxing out at 5. So at 5 units, this becomes a vertical supply curve. So quantity supplied does not increase above 5. Now let's calculate producer surplus, assuming the price of each textbook is $30 in this market. Here I'm working with a table question. So price received by each seller is 30. And first we have to figure out how many of these sellers are willing to sell the good at this market price of 30. Once you have figured that out, you will only calculate the producer surplus for those sellers. Anybody who's not selling the good at that price, their producer surplus is simply not calculated because they're not part of the market outcome. So remember, your producer surplus is your price received minus your marginal cost, or simply your cost. We can also write this as price minus minimum acceptable price. Now, Andrew will definitely sell the good because his cost is only $5 and he is receiving $30. So price is much higher than his own costs. So he goes ahead and wants to sell the good. Brianna will also want to sell the good in this market because her cost is a lot lower than the price received, or the price that she will receive if she was to sell the good. Carlos is also willing to sell his good because the price received is going to be higher than his own cost. So as long as price is higher than the cost, we see all these three sellers at least are willing to sell the good. As soon as you see a seller with a cost higher than the market price, this seller is not willing to sell his or her good. Why not? Because they are going to have a net benefit that is negative. If your cost is higher than the market price, it does not make sense for you to sell the good. You will end up receiving a negative net gain or a net loss of $5 or $10 or $15, etc. So whenever price is lower than your marginal cost, you do not sell the good. So both Desiree and Ellie will not sell the good, or they are not willing to sell the good at the market price of 30. Quantity supplied at price of 30 is only 3 units, and the people who are selling it are Andrew, Brianna, and Carlos. We can now calculate the individual producer surplus for each one of them. So price received minus cost, so 30 minus 5 is 25. Then the next one, 30 minus 15, net gain to Brianna, and net gain for Carlos is only $5. Total producer surplus in this market would be the summation of these individual producer surpluses only for those sellers who end up selling the good, and that is $45 in this particular case. Now we have a market price of $30. So what is the producer surplus? Producer surplus will only be calculated for sellers whose marginal cost is lower than the market price. So Desiree and LA are not part of the market outcome. Only these three are. Quantity supplied is 3. And the producer surplus at the market price would be the summation of these individual producer surpluses. And as we just saw in our table example, that comes out to 5 plus 15 plus 25 for Andrew, which is a total producer surplus of $45. So our producer surplus is essentially the area above the supply curve and below the market price. So area between the price and the height of the supply curve till our quantity supplied. We can also apply this to continuous supply curve, so a linear supply curve as we saw in chapter 3. So in this case, the vertical intercept is 2, and we have an upward sloping supply curve showing us our typical relationship between price and quantity supplied. If market price is 5, your producer surplus would be the area again above the supply curve but below the market price till the quantity sold. So if the price is 5, our quantity sold in this case is 1 million units, and we have a producer surplus indicated by this red triangle, the shaded triangle. So producer surplus again is the area of this triangle, which would be half times base times height. Why is this area important? Because this area is giving you the difference between price minus the cost for any given unit all the way up to these total sold units of 1 million. So this area of the triangle in our case is half times base, which is 1 million, times the height of 5 minus 2 would be 3, and that is equal to $1.5 million. Next, let's look at the change in price and its effect on producer surplus. So let's assume price is rising. So just like your consumer surplus was affected by a price change, here we'll again see when price changes, there are 2 particular effects on producer surplus. The first one is note what happens to the producer surplus of your original sellers, people who are willing to sell the good at the old price. What's happening to the producer surplus as price goes up or down? In this case, price is going up. So remember, producer surplus is your price minus cost for any given seller. So if price is going up, you can see the net gain to the individual seller who was already selling the good at the lower price, it will definitely go up. So your producer surplus is increasing as price goes up, and this effect is coming from your original sellers. Secondly, note that when price goes up, you have more sellers induced to sell the book at the higher price. So you'll also see some additional sellers whose net gain must be included in our total producer surplus. So producer surplus will always have 2 types of changes, and together we'll see the overall impact on producer surplus whenever price goes up or down. Let's see this visually on our diagram. So it's the same old supply curve with an intercept of 2. Original price was $5, and let's assume the quantity sold at original price was 1 million units. As price goes up to $7, we have 2 different impacts on producer surplus. The first one is coming from the effect on original sellers. So these sellers are all selling the textbook at the original price of 5. As price increases from 5 to 7, each one of them sees a $2 net gain. So their producer surplus is rising by $2 for each one of them. So if we multiply 2 by 1, that's a net gain of $2 million. Price has gone up, so we have more sellers induced to sell the textbook. So this little triangle over here is giving you the change in producer surplus coming from additional sellers willing to sell the good or now induced to sell the good at this higher price. So the change in producer surplus would be the darker area over here of $2 million. And we also can independently calculate the area of this little pink triangle as half times base times height and see what is the additional producer surplus coming from these new sellers. Total change in producer surplus would be both of these areas together. So if I label this as A, B, C, my original producer surplus at the lower price was just area A, and my new producer surplus as price is going up is APC, and the change in producer surplus is of area B and C both. B is coming from the effect on original sellers, and C is a positive net gain coming from new sellers induced to sell the good at the higher price. Total surplus is simply the summation of the net gain of consumers and producers who end up exchanging or trading the good in this market. So all we are doing is looking at the total gains generated in this market when exchange happens. So total surplus is quantifying the effect of overall welfare created in this market because of trade. So this is essentially capturing the gains from trade that we see happening because of exchange occurring between buyers and sellers. So total surplus is simply the summation of consumer surplus and producer surplus. And on our diagram, it's this big triangle, combination of both the blue and the pink triangle. So total surplus is all of this area, consumer surplus plus producer surplus. So these are the gains from trade that we see happening in this market because of exchange between buyers and sellers. Total surplus is the summation of these two, so I can write this as willingness to pay minus price was your consumer surplus, and difference between your price and cost is your producer surplus. Note when I sum these two up, my total surplus is essentially the difference between willingness to pay minus the cost for each unit of the textbook exchanged in this market. When we sum it up over all textbooks being sold or exchanged, we get the total surplus in this market, and it's capturing the gains from trade happening in this textbook market. Likewise, for any given market, we can capture the total surplus or the total net gains that we see in this market because of exchange occurring. So trade is making everyone better off. At least people who are a part of the market outcome are receiving some net gains, whether they're consumers or producers. The total net gain is captured by total surplus, or the total welfare created in this market because of exchange happening is captured by total surplus. So at equilibrium, our total surplus would be simply the area below the demand curve but above the supply curve all the way to your equilibrium quantity exchanged. So it is this entire area which is the combination of your consumer surplus and producer surplus. Both consumers and producers are better off when exchange happens in this market. This is what we are capturing through the concept of gains from trade. But are they as well off as they could be? This question is essentially related to the concept of efficiency. Remember, an efficient outcome is an outcome where now you can no longer make yourself better off without hurting someone else. Efficiency is a situation where you have exhausted all missed opportunities to make yourself better off without hurting anyone else. So let's see, is the total surplus really maximum at our equilibrium outcome? In order to see if total surplus is really maximized at equilibrium, or the market, in other words, is it really efficient at equilibrium point, we can try some alternatives. We can see what happens to total surplus either by reallocating consumption. We can also see the impact of reallocation of sales and its effect on total surplus, of course. And lastly, we can see how total surplus or efficiency is affected if we change the quantity that is being traded in this market. So let's go over them one by one. So let's start with reallocating consumption between different type of consumers. So we know when we're working with a price of 30, only those consumers end up buying the good who are willing to pay a price of higher than 30 or equal to 30. So let's assume Anna is willing to pay $35 and Braxton is only willing to pay $25. From our rational analysis, we know in a market where there's free trade and there's no coercion, Anna will end up purchasing the good and Braxton will not purchase the good because his willingness to pay is a lot lower. So Braxton was only willing to pay $25. If we forcefully reallocate consumption from Anna to Braxton, what is the impact on the market and what's the effect on consumer surplus? Note, we are still working with a price of $30. Total quantity traded will not change because we are taking the textbook from Anna and saying you cannot buy this textbook, but instead of you, Braxton will buy this book. So when we change this sales, when we reallocate this consumption from Anna to Braxton, what is the impact? Initially, Anna was purchasing the textbook, so she was making a net gain of $5. $35 was her willingness to pay minus the price paid. Remember, willingness to pay minus price will give you the consumer surplus for any given individual. So Anna had a net gain of $5, but if you take away the textbook from her and you say you cannot buy it, the market loses this $5 of net gain that was coming from Anna. And now we are forcing Braxton to buy the good. Now, Braxton was only willing to pay $25, but he's forced to pay $30. So when you reallocate consumption from a consumer who was willing to pay more to a consumer who was willing to pay less than the market price, we actually end up making the market worse off. Anna is losing $5 of net gain and Braxton is forced to buy the good and therefore incurs a net loss of $5. Total loss is of $10 because of this reallocation of consumption between these two different types of buyers. So we see if we force buyers who were not willing to buy the good at a market price to purchase it, it will actually reduce our consumer surplus. And if your consumer surplus is going down, definitely total surplus will also go down. So by reallocating sales, we cannot increase total surplus. In fact, we have ended up reducing the total surplus in this market. Let's now do the same, but now for sellers. We know that a seller will only sell the good in a particular market if the market price is higher than his own cost or it is at least equal to his cost. He or she will never be induced to sell the good if the market price is lower than his minimum acceptable price or the marginal cost of producing that good. So working with the same, rational sense, we know that if the market price is 30, Yvette is definitely not going to sell the good at the market price of 30 because her cost is 35. Remember, the height of the supply curves gives you the marginal cost or the minimum acceptable price. So Yvette is definitely not interested in selling the good at a market price of $30. Whereas Xavier is definitely willing to sell the good at the market price of 30 because his cost is only $25. So if we let the market be, Xavier would be one of the sellers willing to sell the good at a price of 30 and make a net gain of $5, and Yvette would simply not be part of the market outcome. Now let's reallocate the sale from a low cost seller to a high cost seller. So when we force Yvette to enter the market and participate in this market outcome, what happens? Xavier is now forced to not sell the good. So we lose that $5 that he was making. And Yvette is forced to sell the good even though she's producing the good at a much higher cost. So for her, producer surplus is actually a net loss. Remember, producer surplus is price minus cost. So her cost is 35, but she's only receiving 30. So she's making a net loss of $5. So when we force producers to sell the good who have a high cost given the market price, we will end up making a net loss. So total surplus will definitely go down. Producer surplus is going down by $10 and overall total surplus will also go down by $10. We see that by reallocating sales from low-cost producers to high-cost producers, we actually end up reducing total surplus. So efficiency is compromised when we're trying to reallocate sales. And lastly, we can see what is the impact if we change the quantity exchanged. Now note in the last two examples, there we saw that total quantity exchange was still the same. We were just forcing someone who was not participating in the market to now participate instead of someone who was already a part of the market outcome. So quantity exchange had not changed in our earlier two scenarios. So remember, at a price of 30, who buys the book? Anybody who's willing to pay a price of 30 or above. Who sells the book? Anybody who has a cost of 30 or lower than 30. Right? That's the normal equilibrium outcome. And we are testing what happens if we force quantity exchange either higher than that or lower than that. So let's say we restrict our sales at this particular level. So Anna and Xavier are both part of the market outcome, because if price is 30, we know Anna is willing to pay this price because she's willing to pay 35, but the market price is 30. So she was making a net gain of positive 5. And Xavier is also part of the market outcome if there's no intervention in this market, because his cost of producing the good is $25 and he's receiving a price of 30. So Anna and Xavier, if they were allowed to participate in the market in a free market, they would together generate a net gain of $10 in this market. If they're restricted from participating in this market, this gain will not occur. So the market will actually lose $10 if we restrict sales between Anna and Xavier. Likewise, if overall quantity exchange is restricted at this level and these sales do not happen, which otherwise would have in a free market, we lose all of this surplus. So this whole area would be lost. Your total surplus loses this shaded triangle because these exchanges are now not occurring. We're forcing market participants to not trade with each other and therefore reducing total surplus. Likewise, if we force sales above the market outcome, so the market outcome is 1,000 textbooks exchanged. Now, if you're forcing more people to participate in this market, let's say we force Yvette and Braxton to participate in this market. Why was Yvette not participating in this market? Because her cost of producing the good is higher than the market price. So in a free market, she would not participate in the market. Why was Braxton not buying the textbook? Because he's willing to pay a lower price than the market price. So he was simply not participating in the overall equilibrium outcome. He did not like the market price of 30. Doesn't make rational sense for him to participate. If we force exchange to happen for all of these units which are above 1,000, what are we essentially doing? We are essentially forcing sales between units whose marginal cost exceeds the marginal benefit in this market. Remember, your demand curve is your willingness to pay or marginal benefit curve. Essentially, what we are saying is Yvette is forced to produce the good at a price of 30 when her own cost is 35. So the market makes a loss of $5. And Braxton is forced to buy the good when he's willing to pay only 25 at a price of 30. So that's another loss of 5. So if we force exchange between Yvette and Braxton, total surplus again declines by $10. Likewise, for all of these units between 1,000 and this point, let's call it Q2, all of these exchanges are incurring a net loss in total surplus. So whenever we see quantity exchanged is higher than our equilibrium quantity, or it's forced to be higher than equilibrium, it will end up reducing total surplus. By how much? By this area over here. Likewise, as we did earlier, if exchange quantity is restricted below this equilibrium quantity, we are letting go or foregoing this total surplus or this shaded area over here, which is indicating the loss in total surplus because of restriction in quantity exchange. So what does this analysis tell us? That total surplus is always compromised when we try to reallocate sales from consumers who have a higher willingness to pay than the market price to consumers who have a lower willingness to pay compared to the market price. Total surplus is always compromised when we try to reallocate sales from producers who have a lower cost compared to the market price to those sellers who have a higher cost compared to the market price. And thirdly, total surplus is again compromised whenever we try to change the exchanged quantity. If we restrict sales below Q star, your equilibrium quantity, or if we force sales above Q star, we will end up reducing total surplus. So your equilibrium outcome is also your efficient outcome in most cases because it's maximizing the net gains being produced in this market, or net gains that are being received by producers and consumers. They are maximized at equilibrium point. They will definitely go down if we were to change our allocation of sales or allocation of consumption or changing our quantity exchanged. So summarizing that, we can see most equilibrium outcomes will give you efficient outcomes. So total surplus will be maximum possible, as well off as consumers and producers can be given a particular demand and supply curve. A free market is allocating consumption to always those buyers who value it the most. A free market and competitive market will allocate sales to those sellers who can produce that particular good at the lowest cost possible. A market will automatically not allocate sales to those producers who are producing at a high cost compared to other sellers. Thirdly, all transactions in a competitive market are mutually beneficial. So we end up seeing exchange happening between a seller and a buyer, where we see marginal benefit is exceeding marginal cost. Marginal benefit is typically higher than or equal to price, and marginal cost is lower than or equal to price. So when exchange occurs between that buyer and seller, both are receiving some net gain. So we are seeing that mutually beneficial transactions are happening in this market, and as long as those opportunities are available, exchange will keep on occurring. Once the possibilities of mutually beneficial transactions have been exhausted, that will be your equilibrium point. Now, if you force quantity to rise above that particular level, you will see that we'll end up making total surplus lower, and there are no missed opportunities at equilibrium. We have exhausted all opportunities of making someone better off without hurting someone else. So summing it up, most competitive market outcomes are your efficient outcomes. So we captured efficiency on this market by looking at total surplus, and we concluded that total surplus is typically maximized at your equilibrium quantity and price.